Hello viewers, welcome to the Betikrame Tech YouTube channel. Today I will show you how we can practically control a higher capacity load by S7-200 PLC. We used here the heater, and let's say when it switched on, then the power supply is available and heater is also on. Again, when we completed its time, then the heater will off. You see, again we can see the heater is on, energized, and manually time reduced. You see, time completed, MIT contactor de-energized, and heater is also off. Now we can control this circuit or this heater coil by PLC CPU. We will open this coil here. This is 220 volt AC coil. This is neutral, this is phase. Here neutral will connected, and we will open this contact, and then we use the output of from the PLC, and after connecting the PLC output here, we can see how we can control the heater or load by PLC CPU. Here is the electrical diagram. Here we used a fuse, a switch, magnetic conductor and timer, and as a load the heater. Here is the specification. Timer, this is on delay timer 30 minutes, and magnetic conductor whose coil contact is 220 volt AC, and a tremolo switch, and also here is used a socket, and a heater load is 2000 watt. When we switch on this switch on, then at the same time through this timer close contact, the magnetic contactor will energize, and while this magnetic contactor will energize, then this contact will close, and supply from phase through this way to this heater will on, and at the same time when time will completed, then this timer will energize, and this contact will open, and this magnetic contactor de-energize, also its contact will open and heater will off. Now we'll see how we can control this heater by CPU, PLC CPU. Here is the PLC S7-200 CN. You see, this is Siemens brand, and here is the input I0 0.1 to 0.7 and I1 1.0 to 1.5, and the output is Q0 and Q1. Here is Q 0.0 to 0.6 and Q1 0 to 1.1. Here we used the output. First one is Q 0.1, the light will on, and after 5 seconds in the ladder diagram we used a timer circuit. So after time period, here we selected the time 5 seconds. After 5 seconds we will get the output Q1, Q1.1, and we will use this line to this magnetic contactor contact. Here we will open this line, only use this magnetic conductor, and also this circuit will available. So when we will get supply from this contact, as this contact will open, so current will flow through this way to magnetic contact will energize, and at the same time this magnetic contact will close and heater on. And after when we will switch stop, then this output Q1.1 will out, and this magnetic conductor will de-energize and heater will off. You see, here we used two input signal I0.1 and I1.1, When we start switch, then the supply will available to I 0.1. Here the CPU supply voltage is 220 volt AC. This is line neutral and the line is connected parallelly 1L, 2L, 3L, you see. And when this input is available, the PLC will deliver a 24 volt DC output. So here is a line L plus M. Here is 1M, 2M. So this contact is connected, and here is positive voltage 24 volt DC output. Also we can use if we want to use different DC voltage or another AC voltage, then we do not use this DC voltage, only we use this 1M and 2M, the negative, and other positive connection we will use this line. So here we used the output voltage 24 volt. So here is connected this start and stop. We used the two switch, and when this switch press, the 24 volt DC will at the point I 0.1, and when we switch stop, then power supply will be available to 1.1. So practically we will see how this circuit will open, and here we saw theoretically how we will connect the PLC and the electrical circuit diagram. Here we use heater. Also we can use a motor or another load in lieu of heater. If a three-phase motor is used, just here the three-phase contact we will connect to this magnetic contactor contact, and this side we will use the motor load connection. This is same as like this, just only three-phase and single phase. And in this way we will control this heater by this PLC CPU. Here you see this contact is dotted line, so we will see open this contact, and we will use this line to the magnetic conductor, and also it will works. And this is the theoretical explanation, and after connecting the practical diagram, we will also see its works. The PLC CPU power supply is 220 volt AC, so we connected its power supply from this cable directly. Here we used a timer circuit. Through its close contact, the heater will on. When here we open this supply by this output from PLC. This is output from PLC. Initially, when we used this supply, when switched on the timer, you see the power is available. Okay. Again, when we switched off, then off, power is off. Again, at the same time, the timer will count its time. When time will finish, then its close contact will open, the timer energize, and close contact will open. Supply will off. When we switch on, then instantly power will available to this contact, and when timer is elapsed, you see there is no power. Again you can see that power is available, and you see time is completed and its contact is opened, and the power is not present here. So we use this circuit to control the heater. The heater load is 2000 watt, and now we will use, this is an output contact of the PLC. You see, here is the PLC. You see, this is CPU, and we connected here. There, here the two push button switch. Here you see this one, and also this is power supply, and also this is power supply, common power supply from PLC CPU. Here you see the input signal is here, and this is parallel connection, and this is to input signal. You see this 2-1, this is I 1.0, and also this is I 1.1, the switch, and to here a signal used a load Q 1.0 and another is Q 1.1. This output is connected to the heater. You see here the Q 1.1 is connected here, and here is a circuit. You see, this is timer circuit. Through this timer close contact, here is, you see, here is a power supply. When will switch on, then power will available here, and when we switch off, then the power will disappear. So this connection is available through the close contact of this timer. When time completed, then the timer will energize and this will off. You see, timer off, and here power is not present. Again you can see when switch on, then power is available, and we here manually we reduce the time, and you see time completed and power is off. So we will show you here this connection is open, and here you see this, here is no power, and when we switch on, then power will available here. This connection is to the from the PLC CPU. This is from PLC CPU. Here Q 1.1 according to our PLC program. When we will switch on, then Q 0.1 will available, and after 5 seconds that timer contact is used. After 5 seconds Q 1.1 will on, and when Q 1.1 will on, then power will available to this line, and it is connected to the coil of the magnetic conductor. You see here magnetic conductor, one side is connected. Here you see magnetic conductor, one side is connected to the neutral and another is connected to the coil. So when this is AC supply 220 volt, so but here our controlled, the PLC CPU control power supply is here, control power supply is DC. Okay, DC 24 volt output here, and we used here the contact 220 volt AC. So you see here we switched on, we will see the heater. At the same time you see we switched on. You see the output here Q 0.1, and after 5 seconds Q 1.1. you see here is also for now available. You see, and heater is on. You see power is available here, and when we switch off, then the heater will off. From here we switch off. You see the Q 1.1 will stop here, stop, and also our this magnetic contactor power is off. This is off and heater is off. You see here the heater is also off. Again we can see this. If we switch on, then this Q 1.0 is on after 5 seconds. Q 1.1, Q 0.1 for this light output Q 0.1, and Q 1.1 the heater connection is on. We can also see here, you see this is available. This is available here. You see this is available, and we just stop, then it is off. When we again start, you see start, and after 5 seconds they on, power available, and also heater is on. And here the timer circuit is for electrical connection we used here. When the time will completed, then this contact will energize, and also the power will off. This contact is used only for this line, so here we opened this line, so we used here the PLC line, so heater is on, and we stop here from the PLC panel. In this way we can use a motor or another big load or higher load by PLC. Here the PLC output is connected to the coil of this contactor, magnetic contactor. Here is 220 volt magnetic contactor. Its contact a single phase, so here neutral is, you see this is magnetic. Here this is magnetic conductor, and its coil power supply is 220 volt AC, and you see this is single phase, so I parallelly connected its 3 open contact for safety, because current will flow through this parallel contact. So here you see this heater coil connection is here, neutral is connected directly, and this phase is connected to through this contact. When this magnetic contact will energize, then power will available to this line and heater will on. So here the neutral is short, its coil, and phase is connected to from this CPU. In this way we can control the heater by our PLC. Okay, now the heater is off and magnetic contactor is also off. You see this is, we switched on. After 5 seconds the magnetic contactor is on, and also heater is on, and again when we press stop switch, and then magnetic contactor is off and heater is also off. In this way we can control a large or higher load by a PLC. And here the heater load is like 2000 watt, 2 kilowatt, so also it is a big load. So like this circuit we can control a AC higher load by the PLC CPU. Thanks to all for watching this video. If you like this video, please subscribe my channel and also like and share this video. Again, thanks to all.